Okay, calculate average rate of change. So my average rate of change is going to be the difference in y over this interval divided by the difference of x. How far you move up and down compared to how far you move left to right. It's very similar to, in fact, it's the same formula as my slope formula, y2 minus y1 over x2 minus x1. But usually we write it a little bit differently, function notation. F of b minus f of a over b minus a. Okay, so these are y values, function values, outputs. So f of b minus f of a means how far it changes up and down. B minus a is how far it changes left to right. So you might be able to guess, as I travel from -1 to 1, I'm going 2 places. Well, the math should work out then. If this is a and this is b, then b minus a is going to be 2, right? 1 minus -1 should give me a 2 in the denominator. That's the easy one to calculate. Now f of b, I got to do a little bit of work. F of 1 is 5 times 1 squared plus 8 over 1 cubed. And that's just 5 times 1 plus 8, that's 13. F of -1 is 5 times -1 squared plus 8 over -1 cubed. So we got to be careful with this one. -1 squared is +1 times 5 is 5. And -1 cubed is -1. 8 divided by -1 is -8. So 5 minus 8 would be -3. Okay. So f of 1, right? That's in this is f of, in our formula, f of b, and -1 we called a. So f of b is 13. F of a is -1, -3 rather. So I end up with 16. 13 minus -3, 13 plus 3, 16. So my average rate of change is 8. Okay. All right. Next question is the same. They're just going to put a b in there instead of a number. So b represents a number. We don't know what it is, but we have to get used to this algebraic method and using symbols that represent numbers. So let's see how that works. I'm going to use the same formula. My average rate of change is f of a minus f of b over, same formula, f of b minus f of a, f of b minus f of a over b minus a equals. Now this is going to be a little trickier. That's a, and good news, b is b. Okay, so what is b minus a? Well, b minus 1 is b minus a. A is 1. B is b. So that's the best I can really do with the denominator. I can't simplify b minus 1 if I don't know what it is. Okay. In the numerator, let's do this first. F of b minus f of 1. And then we got to figure out what those is, just like we did in the last example. Only f of b is going to look a little funny. F of b is, that means I plug in b here. 6b, 6. Sorry, I was trying to fix my pen here. 6b squared. Okay, again, so here's my function. Let me circle it. I got to plug in b to that function. So what's f of b? I plug in b everywhere I see an x, so it's 6b squared minus 4. And again, that's all I can do with that thing. That's f of b. F of 1, just like in the last example, I can figure that out. 6 times 1 squared minus 4 is 6 times 1, 6 minus 4 is 2. Okay, so this is equal to f of b, which is 6b squared minus 4. 6b squared minus 4. That thing is f of b minus f of 1, which we know is 2, all divided by b minus a, where a is 1. Okay, So the best I can do with this thing is just clean it up. So I got 6b squared minus 4 minus 2. That's 6b squared minus 6 over b minus 1. And that is my average rate of change dependent on b. However, anytime we can try and simplify my fraction, in this case, I could factor out a 6, b squared minus 1. And on the bottom, I got b minus 1. And hopefully recognize b squared minus 1 as the difference of two squares. That's a b, not a 6. B squared minus 1 factors as b minus 1, b plus 1 over b minus 1. And they cancel out. And I get a reduced fraction, 6 times b plus 1. Okay, one more. Same thing, but we're using a graph. So I want to use the graph of f to evaluate the following. The average rate of change from 0 to 3. Okay. So, close that guy off. Same thing. It's going to be f of b minus f of a over b minus a. Again, this is how far does it travel from 3 to 0, divided by how far it travels x going from 3 to 0. Let me say that again. Average rate of change is how far it travels on the y values, f of 3 from f to f of 0. F of 3 is right here, has an output of 4, right? We don't plug it in to a function because we don't have the function rule like we did in the previous examples, but we have the graph. What's f of 0? Where on x is 0, y is 5. So you can see that f of 0, input 0, output 5. Okay, so this is helpful in understanding the average rate of change because the y value, how far does the y value change from f of 0 to f of 3? It changes by 1, right? It just drops down 1. And we get that algebraically from the formula because f of 0 is 5 and f of 3 is 4. So when I do that, it looks a little bit easier, right? It's 4 minus 5 over 3 minus 0, which is negative 1 over 3, which is negative 1/3, and that's my answer. Now, since we have the graph here, we can make some connections. I told you at the beginning that this is really the same as the slope of a line. If you connect these 2 points, then the formula is the same as the slope of a line, right? So if I draw a line through those 2 points, what's the slope of that line? Well, if you remember slope, you go over 3, down 1, right? Over 3, down 1. Same exact formula. And I get my average rate of change.